Good morning for the 3CX Advanced Training Day 3. I just want to confirm quickly that if everyone can see the shared screen and if you can hear my audio. Cool, thank you very much. I think that's sufficient. So before we go into the basic troubleshooting, I would like to add 2 points to the session from yesterday, which in the end link back again to the basic training, which we had on the first day of the basic training when we were talking about 3CX, free and SMB. Of course, be aware that when you start to plan a system and you start to plan the system using a 3CX free or SMB license, you will not be able to upgrade the system that you created for your customer to any other system. So you will not be able to upgrade to 3CX hosted in a point if the customer comes to the limit of, for example, 20 users. You also will not be able to upgrade to 3CX dedicated, be it Pro Enterprise. There is no upgrade path at the moment. I also don't know if that ever will come. The reason being is that when we use 3CX free or 3CX SMB, we're actually sharing a 3CX system. So these instances where you deploy 3CX free and SMB on, they are shared with a couple of hundred other instances, departments in the end. It's coming down to that when you create a user for free or SMB, you create a department. And that department then in the end sits on a 3CX. So from that perspective, there is no upgrade path at the moment. And there is also no way to take a backup in that situation. That's just because the system is not built like that. So you can't take a backup per department. So which means when you have a user that runs or uses a 3CX free or SMB and you have to take a backup of that user, there's no way to take it. Unless 3CX has something that they offer, but I doubt so. So you would have to, if you have to upgrade to a bigger version, you would have to install the whole system from scratch. That's how it is. Okay, so again, then there, when you come to the situation of planning a system, think about if you go with a free SMB and in half a year, you have to rebuild everything from a start, from absolutely zero, or you go straight away to a small pro license where you then can upgrade to enterprise and to multiple simultaneous calls and all that stuff. So it's just coming down to those decisions that you have to make at the very beginning. I know the situation that the customer often says, oh yeah, no, that's no issue for me and all that kind of stuff. Yeah, I just want it like this. Then further down the trail, when the customer then comes to the point to that he has to upgrade because there is no or everything has to be done new because there is no pathway to lift the system. The question comes, why haven't we done that at the very beginning? I know that already from I have been there in the past as well. So think about very well which way you go. Of course, it would be better to lead the customer to use a pro. It's not because we sell more. Of course, we sell more in that regard, but also with an SMB, we sell. It's literally coming down to the ease of use for you and the customer. That's it. Yeah. Okay. Cool. Then we go into the second last chapter of the official training. We look into basic troubleshooting. 3CX is strongly relying on, first of all, self-help. I would say everyone more or less does that. Also the phone manufacturers, they rely in the first way on self-help. We have the dashboard that can be used. Quickly turn on the pen here. We have the dashboard that can be used. We have verbose logging that is available. We have event log. We have audit log. We can configure email notifications. We have VoIP connection monitoring, and we have packet capture Wireshark. 3.6 hosted, they had to turn the packet capture Wireshark off for certain reasons. I'm not going deeper into that now. It's just the point that they had to turn it off for security aspects. People who know how that stuff works, they can imagine what the situation is. Okay. The dashboard gives a quick overview over current activity and status of the PBX. We can see here we have the FQDN, we have the IP address, we can see the trunks. Of course, the green tick box requires that the trunks are all supported. We see here the install type hosted by 3CX. We see that the phones are all okay. We see our ports that we have chosen. We see also these ports here. We see if the system extensions are up and if the audit log is enabled. Then again here, auto updates, since this is hosted by 3.6, auto updates are enabled. Recordings, we can see, is enabled. Archiving is enabled. So from that perspective, we only use a very, very minimal amount of recording on the site. We have the chat log that is disabled. This can be enabled, of course. Automatic backup is enabled. We see the amount of unused firmware files. We can also clean up there. We have the call log that we could purge. However, that would then delete all calls from the system. So for example, the whole call history would be gone. We have the indication if the services are up and running. We can see the logging level here. The restart operating system button, which is new introduction to version 20. So for example, when I click this one, I can literally restart the phone system. And we see if the firewall the firewall checker has been run successfully. We can export system health, system info, IP configuration, overview, processes, connections. And then we have also here the opportunity to generate support info. You see here, packet capture is grayed out. because it's on a hosted system. And then we can also perform database maintenance. Don't ask me yet what this is doing in the backend. Again, it's version 20 is pretty new. I have not been playing around with that. And probably when I look on where my journey is going to here, I also will not be playing around too much with this. And of course, we see the version where we are on. And we see it's a beta version, which is in the end a no-go for a productive system. Verbose logging default is low logging because it can create some CPU intense CPU usage. All log files will be cleaned after restarting services or the PBX. So when we are logging something and we require those logs and the system will be rebooted or the services will be rebooted, all log files will be cleaned. So which means the whole logging that we did over the last 2 days is gone. Yeah. Backup of logs can be kept for up to 10 days. For debugging, logging must be set to verbose. And then once the issue has been replicated or found, we can turn it off to low again then afterwards. System health gives us an overview of critical system information, system info, IP configuration, overview, processes, connections. We can look into that then further on the live system. Again, that live system is not really in use at the moment, and it anyway will be cancelled after that training because it's just a trial. Then in the event log, we have summarized events on failed registrations, RPS requests. Then we have 3 levels of events. We have warnings, errors, and informational. The audit log tracks changes made to the 3CX. You can search for changes made and you can export to CSV. Of course, that comes then down on how the logins to the system is generated. If you have a general tech extension, then where you log in all together, then you literally see this person making changes. However, you will not see exactly which extension that is in the backend or which user that is who actually made the changes, because you literally see that the tech extension did the changes, but you do not know exactly which tech actually used the tech login. And then we can configure the notifications. We can add multiple email addresses inside here, comma separated. We can also include the system owner, and then we can we can send email notifications for the events listed. Of course, the question is then how much of those email events do you want to be sent when you have multiple customers that require to have the system monitored. So from that perspective, comes down to how the setup is. Generally, the notification is in a way not much different than, for example, if you use a monitoring tool. Also, they send you notification if, for example, a trunk is down or what else ever, or something is wrong with the PBX. So either you get the notification through here, or you get the notification through a monitoring tool. Again, monitoring tools are not something that 3CX likes to see. Also, we are not telling you which one you should use or what else ever. This is an official 3CX training. So from that perspective, we stick to the guidelines from 3CX. Packet capture, there is a built-in packet capture utility. Windows installation require Wireshark to be installed for this to be available. 3CX usually has, so that the Debian installation usually has T-Shark already installed. If not, you would have to SSH onto the backend and install T-Shark via SSH. Then that is new here. That is a nice one. The VoIP connection monitor tool. That's a built-in connection monitoring tool where you literally can have calls of an extension monitored for a longer term, and you see then literally a rundown on statistics. You see packet loss on either side. So it gives you already an overview if the issue is on your end or on the remote end. You see that's a remote address. You see the codec that has been used. You see here that's the trunk. You see, remember 10,000 from yesterday. Yeah, so you see quite a lot of information on that end if there is actually a issue, especially if it's an intermittent issue, which is always hard to run down, to hunt down. From that perspective, this tool is definitely something that should make life easier to track down intermittent issues like call drops, bad audio quality, and that kind of stuff. We will see then the result of that connection monitoring tool. We will see that in the event log on the call monitor, for example, and then you will have to search for it if you have a lot of other events, and then you can click on the event ID and you see the outcome. Then Wireshark zip flow debugging. We have here literally, let me quickly check if there comes an additional page where they explain it. No, not really. No. So we have literally, bear with me. We have here two call legs. We see two call legs. We mark them both, and then we literally say flow sequence. Then we can see the call flow. We see here the source IP of the caller. We see here the IP address of the PBX, and we see here the IP address of the called extension. The first field here is the invite that's being sent out. Under normal circumstances, it is sent out without authentication information. The 3CX then says authenticate yourself, so it comes a challenge proxy auth request. The caller then says, okay, it's an ACK, sorry, it's an ACK, acknowledge it, sends the zip invite with the authentication information. The PBX response, I'm trying now to call that extension. It says here, trying. Then calling the extension. The extension says trying. You see here the bigger dots are here on the left side here. One moment here. There's a bigger dot. And then it says to the PBX, it's ringing. I don't want that, sorry. It's ringing, and then the PBX sends the information back to the caller that it's ringing, yeah? And then they literally set up the information here, connection information, how they want to talk, how the talk is going to happen, and all that stuff. And then in the end, the call happens. We see here now both are in the same network. They are both in the 1033 or 31 network. It's a 31 network. We see it up here. We see it better. 1031. So which means we will not see, because the capture has been done on the 3.6, we will not see RTP in here. Because what happens is when we are in the same network, so let's say the 3.6 is here, we have an SBC that is somewhere sitting around here. And we have an SBC, and then we have two phones connected here in the back. The actual call goes that way. So the SIP traffic goes that way, but the actual audio, so the RTP, goes that way. It stays in a local LAN, except I have to troubleshoot the audio, then I have to enable on the phone system. PBX delivers audio, and then the audio is also going via the 3CX. Yeah, but if the 3CX is on-prem, or if we use SBC, or if we use VPN, then the RTP, the audio, stays inside the LAN. Now, if we use Stun, for example, we have to enable 3.6 delivers audio so that actually the audio can go via the 3.6. The same here goes if we have the situation where we have the 3CX hosted, and then we would have multiple SBC phones. The phones would sit in the same network, but they are literally connecting all via its own SBC connection. So they all would be SBC phones. In that regard, also the audio goes via the 3.6, but that goes then automatically via the 3.6. Yeah? Okay. Debug of audio issue. Again, we have the same call here. Then we mark both call legs. We say play streams. And then we have 4 streams in here, 2 times direction PBX and 2 times from the PBX to the end devices. Then we see here the source addresses of the devices. We see here one time it's a 213 at the end. Then we have 2 times 169, which is the 3.6, and we have 1 times 108. We see the source ports. We see then the destination address. We see that it either goes from the end device to the PBX or from the PBX to the end device. Then we see again also the destination port. And we also see the packets, we see the sample rates, and we see the codec. SIP messages are generally very clear. we, for example, register the device onto the 3CX, therefore it receives or it sends a register request. When we set up a call, we send an invite because we want to invite the other party into the call. So we send an invite to the other party, which can be an external callee or a local extension. By is used to terminate an already established session. So in that regard, a call. Yeah. So when we end a call, we say bye. It's the normal thing what we do on a normal call. When we are together on a phone call or like when that meeting or that webinar is finished, I also say bye to you because I terminate it. Cancel is used to cancel a call in call setup state. So when you start dialing a number and actually before the call has been established, so while it's, for example, still ringing on the other end, you cancel. You end the call, you hang up, you cancel the call. ACK is used to acknowledge and complete a request response pair. Subscribe is used for requesting statistics, message waiting indicator, and BLF. They are regularly updated, so there is a lot of network traffic created by subscribe and notify message. So they come hand in hand, these two. The phone subscribes, the PBX notifies to deliver statistics on an existing subscribe dialog. So the phone subscribes, for example, BLF for extension 200. Then the PBX is literally constantly sending notifications, updates on the status of that subscribe request. Refer is used for call transfers. Yeah. Then we have Wireshark response codes. 100 to 199 are provisional statuses. 180 ringing, 183 session progress. 200, 299 are final statuses like success. 200 is okay, 202 accepted, and so on. 300, 399 are redirection notifications, for example, moved temporarily. 400 to 499 is local filer. 401 unauthorized, 486 busy here. That's a famous one here. For example, when you do troubleshooting, customer calls you in and says, I can't reach that customer, that extension. That extension is never answering. Yeah, I can't reach them. You make a Wireshark capture, you get that response. Yeah, user is on a phone call all the time. Yeah, could also be that the phone is literally hang himself up, but then you wouldn't generally receive a 486. You would receive something else. But yeah, that's a classic one. Yeah, 500 to 599 internal error, service unavailable, not implemented. And yeah, you have to check what is wrong there with the services, for example. 600 to 699 global failure, busy everywhere, 603 decline, that kind of stuff. That these ones generally, these ones should not happen at all, and these ones can happen in a way. So now, how does a register message look like? Again, like I said before, when we send out a register, in a first moment, we register without sending the authentication information. Again, this comes as well down to the original SIP foundation, where the idea was to do IP calls. And then when you call two devices via an IP address, it's a direct IP call. So from that perspective, you don't need to authenticate yourself. You authenticate yourself to a higher leveled instance, which is a PBX, but you don't authenticate yourself to another end device. You also will see that when you make packet captures, or when we look before here, we do not see that the PBX here has to authenticate itself because it's going down to the device. Yeah, it comes from the server down. So it's, let's say master says something to the slave in that regard. Yeah. So, but when the phone wants to register or wants to register on the phone system or to establish a call, it's literally the same. Wants to register, proxy authentication required, and then we send out the information with authentication. PBX says, okay, registered. Then the expires header, we have that here, gives us the information after which time this message will expire in seconds, which is 120. We see here the IP address of the device. That's the IP address of the device. We see here the IP address of the PBX here as well, because the phone registers under his extension at the SIP server on the SIP port that the SIP server is listening to. Yeah. Then we see the maximum forwards. That is the amount of hops that are allowed. So when you do, for example, a trace route, you see the hops that come up there, and that's the maximum amount that is allowed in that packet. Yeah. We then also see the device. We see the firmware version of the device, and then we see where the phone wants to be contacted back. You see that here. Contact IP on port here. Huh? And we see the wire, every hop literally adds his wire to it. We see it comes from IP from that port. Okay. Now, where do we see there's no MAC address inside here? Yeah, but that's all the information that you more or less can see in this one. Of course, we can also see the call ID here. Now, the call invite, again, we had register. Now it's the invite, it's the same. Proxy authentication required, so the server challenges the phone, accept or acknowledged, and then we send the invite again out with the authentication. 100 trying is then the response from the 3CX server, and that it's ringing on the other side. So you remember the first call flow we looked at, there would have been another phone here. So we would, in between here, then receive the information out invite. Then we would receive the information here trying. Then we would receive the information here ringing, and so on. Yeah, so that would be all then here happening on the remote side as well. Invite, if we look at the invite, we see again here at the top, 102 is the extension, that is the SIP server, that is the port. in this case here now, we have a different phone. We have the phone using that IP address and that SIP port. It is the operator extension that is registered on the SIP server, on the SIP server's SIP port, and calls to the extension 102. Oops, I was wrong up here. It's not that this is the actual phone. That's the invite where we are going to send to the invite 102. Sorry for that one. So here we send the request to call that extension, which is registered on that SIP server. Then we have here the call ID on the phone itself. We see here the contact information is 100 at the IP address of the phone on port 5060. We see what is allowed, invite, info, prac, ACK, buy, cancel, and all that stuff. Again, 70 forwards allowed. In this case, it is a SIP T46G, pretty old phone, on firmware 2883020, and with that MAC address. We can see this is an old slide that's probably that has been reused probably for like the last 5, 6, 7 years in terms of that example, and we see it's literally still the same, because once that the SIP is given, it's literally, there's not much changes to it over the years. Yeah, we see the events allowed, talk, hold, conference, refer, and it also supports replaces. The from header is where the call originates from. So it came from the operator extension 100 at the SIP server 5060 port to the destination of the call, which is local extension 102 at the SIP server on port 5060. And then the contact field is always important, especially if that IP address is not the right IP address, you will face one-way audio, because the audio, the RTP, is then sent to a different IP address. Often also happens is that, for example, when it's an outgoing call, so for example, you have the user here, the phone, you have the phone here, you have the firewall here, the call goes out, and that literally, and then you have here more or less the PBX, PBX, that here on that end here, you have the local IP as contact information, which means the 3CX, or sometimes even also when then on that end here you have a firewall as well, and then we go here through to the provider. Also here you have a local IP, the local IP of the PBX. The provider doesn't know where to send that the audio back to, because local IPs don't exist in the World Wide Web. And also here, where we would this also would be a World Wide Web connection, because the 3CX would be hosted. This would be World Wide Web connection. Also here, the 3CX would not know where to send the IP address back, so they would still try to send it back to that IP address, yeah, but the IP address is not the WAN IP what you actually have here, yeah, or here. Okay, that's just how the whole stuff happens. It's very often one-way audio in the contact field, wrong IP address. Either it's the wrong local IP address if the phones have to be connected locally, or it's the wrong public IP address. It's in most cases, it's the wrong public IP address. The via header SIP responses use the same reverse route as the SIP request. So therefore, you see in the via, you should see then always popping up the hosts or the hops where it goes through. Multiple via lines, for example, each SIP intermediary will add its own address to the via. We see here that's the WAN IP most likely. And then we have here the IP of the phone. Then the caller ID or the call ID header, sorry, is the identification of a call leg. Call ID at IP address, again, that's the IP address of the phone. The C sequence line is used to link packets within a leg together. That's the invite. Then we have the user agent defines the SIP endpoint sending the request response. In our case here, it's a Yealink T46G with that firmware and that MAC address. I told that already prior. Now, sometimes when you go into the activity log, you see, for example, user agent. Friendly, what is it called, scanner or something like that. It's nothing else than SIP wishes, which literally checks if 5060 port is fully open, and then if so, they then literally go and send a couple of botnets against your IP and your 5060 ports and try to literally register. Proxy authentication header used to authenticate the endpoint to the SIP registrar. The initial invite is without the authentication, again, because originally SIP was meant to have two IP phones talking with each other. So then you go from one IP to the other IP and then it's just ringing. The invite here, you see between the contact and the content type is empty. Down here, we have the proxy auth inside. We have the username, the realm, and then we have the nonce. SDP negotiating media exchanges, IP and port to send the audio traffic to the media type that is used and the codec types. So we see here connection information. This has to be, depending on the setup, the IP of the or depending where the packet capture has been taken. This has to be the IP address of the phone or the public IP of the WAN side if it goes out into the internet. So from that perspective, if that is not correct set, then the audio will go to that IP address, yeah? Doesn't matter how the setup is. What is inside there is where the audio goes to, yeah? Then we have here RTP map with PCMU, A, G711, G729, and then we offer here RTP map 101, FMTP 101 0 to 15, which is nothing else than DTMF. Then we have in Wireshark, we have display filters. If we filter for SIP, it shows all SIP packets, regardless of the IP address or regardless if it belongs to a register or if it belongs to a call or what else ever. Filter zip.method equals invite, it identifies all invite packets. This can, of course, be multiple calls. Zip sequence.method equals invites identifies all packets linked to an invite packet. So here you will then not only before you see here, we just saw the invite packets. Here you see the invite packets and whatever comes underneath those invite packets. Yeah, everything that is belonging to the invite. Further filters are what we had here: invite, register, subscribe, and notify. A filter when you have the caller ID, the call ID, sorry, you mark the call ID inside the Wireshark capture, right click on it, apply as filter, choose selected. It then identifies all packets linked to a particular call ID and then applies the filter directly. Then we see down here, we see literally the whole call, excluding the audio. Ask for help when? After reading the config guides, after reading the admin guide, after reading the tech docs, after going to the forum. Who? Active partners. Inactive partners, customers only via ticket. That's literally on 3CX's end, yeah. Help requests about supported IP phones using the default templates, supported VoIP providers, supported 3CX products. How? Via phone, via ticket system, via customer partner portal. 3CX will assist with supported configuration. We cannot assist with unsupported third-party software and also third-party or unsupported setups. 3.6 will not really support any stun setups anymore. Okay, let's quickly jump into the last video we have for those trainings. Is this gonna build up now? That's one moment. That's not what I want. Sorry about that. That was in this case a mistake that happened on the video editing software. So literally what happens here is that I call now an extension, as we can see. So we call the left and the right phone. And then I could literally enable the monitor connection quality there and would be able to see then for the time period for every call that was made in the call log, I would see the call quality. So in the event log. Now, what we do on that's the T54 phone. We start the packet capture on the T54 phone. And we start the packet capture on the T57 phone. I mean, it's okay when the phones literally get covered in the back. You do not really see that much on the phones anyway. It's just answering the call and the call is ended again. From that perspective, it's probably anyway better if you see the full picture here, but yeah, apologies for that. So we have now two packet capture files. One is from the T54, which is local to the PBX, and one is from the T57, which is remote as an SBC phone. So here we see the whole zip information, all zip information that is around. We see here the call from 2000 to 2001. We see that literally both are going via the same PBX because the call goes out via the bridge. It's the same bridge that we had yesterday in the bridging. Now here we see literally the call flow between the phone and the phone system, because I did that capture on the phone. So I only see always the leg with the next endpoint. If we, for example, do a three-way conference between a phone, a local phone, another local phone, an external party, like someone on a mobile phone or on a landline number and the phone system, then we would have 4 points in here. We would have the two phones, two local phones, the PBX and the provider. I would not see the call until the endpoint, the remote person that was called, but I would see it to the next hop, which is the provider. Yeah, I always see it that far. Yeah, so we see now here, even if the other party, the the extension 1000 or 1001 did answer, I only see my call leg from the phone's perspective. Yeah, I only see to the next higher or to the next point. Here we see then again, we see the invite that goes to the PBX. Then the PBX says trying, okay, authenticate yourself first. Then the phone acknowledges, sends the invite with the authentication information. Then the phone system says, I'm trying, it's ringing, and then the call literally is established. And at the end, it is the remote end that says bye. We see here the bye is originating from the PBX and goes over to that local phone here. So which means in the end, the phone that would sit over here was terminating the call, except it would be something on the PBX that terminated the call based on an error or what else ever. Yeah, but generally it is when you see the bye coming here to that side, then you literally know that is the other side who said bye. We then can apply a filter to that literally call leg, and we have all the information we want. We have then inside here, we have the message header with all the via information. Again, there is only now at the moment the phone inside because the packet capture was actually taken on the phone. Then we see the from to information we call from extension 2000 at the IP of the SIP server. Sorry for that. To the extension 1001 at the IP of the SIP server. It's an invite again. We can apply that again as filter. We have the contact information there. And we see the device, Mac, and firmware version, events allowed, maximum forwards and replaces, and so on. Inside the message body then, we have the information on the connection information. We have the media information. And then as well that DTMF is supported. If we look now at the packet capture from the T57, we see that there is no call. There's no SIP information in there. The reason why there is no SIP information in there is that is an SBC device. An SBC device is encrypted. Therefore, we can't gather any SIP information. Unfortunately, yeah. So that's what we have to keep in mind when we use SIP phones, that when we use SBC phones, we can't make packet captures on their end. Fortunately, we do the same story again with building up and building down the video screen. I did forget to put there a marker. It was actually late in the evening when I did that, so I was most likely a little bit tired. But yeah, nevertheless, yeah. Sorry for that. So I'm doing a packet capture now on the 3CX. I start a packet capture on both phones. So I will get the information from 3 different sources. Call in, answer the call, 1, 2, 3, 1, 2, 3, or what else ever I did say there. End the call. Stop the packet capture. Download the packet capture. Stop both packet captures here. And then I will have in the end full information on those calls. I will see here on the 3.6, I will see both call legs from both phones. However, one is coming via the bridge and is also is also encrypted on the phone's end, but I will still see information here on the 3CX. Yeah. So we see now here the phone system is in the middle. We see again the invite comes from the phone with the IP of 86, has to authenticate itself, then the invite is sent out to the called device. Now, do not ask me why Wireshark was showing or is showing the ringing information delayed. That generally should not happen, because literally what happens is the invite goes out and the invite should be straight afterwards, because it's literally like a conversation. Then the information should come back from the phone saying trying, goes over to the caller device, so the initial device saying that it's trying, and then the called device, so the device with the IP87 should say ringing, and that should be sent over then. Don't ask me why this is offset like this at the moment. But again, this is how you would see it, the whole flow. And now, for example, if we would have IP addresses that are inside here, additional, where, for example, the audio all of a sudden would go to, when you see the RTP, inside here goes to an IP address where it shouldn't go, then you know I somewhere have the wrong IP address in my information. Then you also, from that point of view here, you would be able to determine, is it on which phone? Yeah. What you sometimes see when it goes, for example, the phone here, that which is 87, that would be the provider. That could be the case that when you have a VoIP provider who uses a separate audio server, that the audio stream goes to a different IP address than the SIP information goes to. That can happen. That is in a way normal, but then you would see that these IP addresses both would sit in the same public subnet. Yeah, so that would be clear then. So you would have here, for example, an IP address where the SIP information, and then you have further out here, you would have an IP address where the RTP goes to. That is totally normal in that regard then there. Again, we go down here, the whole setup of the call. That is then the T54 device. Again, showing the flow sequence. Here now, we see the RTP, because these phones are both in the same LAN now. It's not an SBC phone anymore, the T57. Both devices communicate. You see the arrows of the RTP. They go straight through. They don't end by the PBX. They go straight from one to the other one. So from that perspective, you see when the phones are in the same network, RTP goes directly between the devices. If I would have had to troubleshoot the audio now, I would have had to say on the phone system, PBX delivers audio. Yeah. And one moment, go back quickly here. What I line out here now is that the capture below, the lower capture, is made on the phone system, and you don't have any RTP traffic in there because it is not hitting. The PBX doesn't see the RTP there. Yeah, so therefore it cannot capture it. So if you have an issue on devices on the audio level, then you either have to make a packet capture on the two phones and see where the audio goes through there, or you say, okay, I capture it on the phone system, but then you have to enable PBX delivers audio, of course, depending on the setup. Yeah. If you have on-prem PBX, the PBX will, under normal circumstances, not see the audio going via the PBX. It goes from end device to end device. If it is a hosted PBX with an SBC on site, can be one SBC phone, multiple SBC phones which have normal phones behind them, or it is a single SBC, you generally will not see the audio traffic on the PBX. Yeah. If it's with stun devices, you anyway would have to enable PBX delivers audio there. The audio then makes a loop. Yeah. So it's literally always coming down to the fact how the setup is working. The buy here goes now in both directions since I did the capture more or less or the core control using the soft client. So from that perspective, it is the PBX that in the end sends out the buy and none of these devices. Now that is on the normal IP phone on the T57. We then again see here, it's a little bit different lined out. We have now here on the left side, we have the PBX and we see the invite comes into the phone. And then we have the audio going between the two IP phones. I love it when Wireshark decides to crash. It closed all the window and then the main window was still open and then it's just crashing. But again, that is now literally the whole call between the two phones and the phone system. That's just all the SIP you see in the protocol section. We have all SIP and SDP information inside there. And here again, we see all the wire headers and the from and to information. It is in the end, not much information in there because both are in the same network. They're both in the same local network. So there's no additional wire header in the packets. And you see further down, it's just blanked out now from what I wanted to show. Didn't press anything. You see the proxy authentication information. We see the username. We see the realm. We see the nonce. And we also see then the response. So it's literally everything in there what is required for the call invitation there for the call setup. Yeah. Again, we have the phone, the firmware version, the MAC address. Again, the connection information where the packets have to be sent back, so the audio packets. We have the RTP map and we have the DTMF information. It's literally everything inside there. And the same we will have here inside the other call. Now, here we have the RTP information. RTP information generally doesn't give you a lot of information inside there. It's very, very basic. There's not much what you can see. You definitely can see the source and destination port inside. You can see the source and destination IP address inside. But again, there's not much information. We are in an invite packet at the moment, by the way. Inside the RTP packets, generally, there's not much information. If I would go into the RTP streams now on the PBX, I have nothing inside there because the audio was going between the end devices. It went between those two calls. You see the PBX, as we said before already, had no RTP inside. In this case, I would have to go into the devices itself, so into the capture from the two devices, and then I can mark either one or both streams, and then I can say prepare the filter, and then depending on Wireshark, it might take hours or not, and then you literally see the audio. You can play that. You can also export that in terms if you have to show your customer something in that regard. You can also analyze it, where you literally see the jitter information inside, which can always be an indicator if the internet connection or whatever kind of connection is okay or not. that is now a local network, so the expectation that the call is good is actually should be given. Okay, so that in the end was now the demo of Wireshark packet capture. Any questions? I see there is one question around. So someone has to leave early. Thank you for that. Just letting know that he leaves. Are there any further questions in that regard? I know it can be quite complicated and confusing, but you have to work yourself inside that kind of stuff. The more you do it, the more it becomes clear, and it helps you a lot also in order to break down issues and troubles that you will face or that you might have on the customers end to actually solve them in a faster way when you are able to troubleshoot using Wireshark and other of those devices or tools.